Alright, hi folks. I'd like to discuss the difference between a progressive and a stationary wave. This is a common question in superposition because our examiner wants to test our understanding of the properties of the two. Okay, so before I begin, let's do a recap of phase difference, because you're going to be seeing this as part of the properties of comparison. Alright, so you see, if you have an oscillation, we can always depict it in terms of a displacement time graph. So the particle starts from equilibrium, goes to its amplitude, back to equilibrium, down to its lowest point, and then it completes one full cycle. That's the period. Okay, this is half the period. Now in math though, right, we can also use a displacement against angle, right, graph to depict this. And so one full period actually maps to an angle of 2 pi. Then half a period, 2 pi. Okay, and that's actually phase angle. So the phase angle is a fraction of a cycle times an angle of 2 pi. Right, and so once we can actually denote something called the phase angle, we can also find something called phase difference. Okay, so what does that mean? Now, if I want to find the phase difference between two particles, say we have a phase difference of 2 pi, right? So a phase difference of 2 pi means that one particle now completes one full cycle, and then the other particle starts. Okay, so a phase difference of 2 pi is actually, particles in phase, or we can also call it a phase difference of 0. Now, on the other hand, let's say we have pi, right? So pi, that would be half a cycle, and the other one starts. So subsequently, the particles will always be doing the opposite motion to each other. All right. If I want to do pi over 2, right, so pi over 2, that will be a quarter of a cycle apart. Right, so it's pi over 2. Okay, so the first particle will have to reach its amplitude, and then the other one starts. So it's something like this. So I have to focus a bit more because I have to split my mind to control the two hands. Okay, right. So now we have this understanding of phase difference. Okay, let's then look at a progressive and stationary wave. So first, let me show you what the stationary wave, progressive wave, right? So let's look at the progressive wave first. Okay, now so the progressive wave, right, looks like this. So you have a orange wave that is traveling to the right. And on this orange wave now, there are 4 particles that are chosen. You've got the blue, the orange particle at 0.25, the green particle at 0.5, and then the red particle at 1.25. The wavelength is 2 meters. Okay, now the graphs below, this actually maps their displacement against time for the 4 particles. Okay, instantaneously, you find that they have different displacement, right? But they all have the same amplitude. Okay, now since we just did phase difference, okay, so let's choose the orange particle at 0.25 meters, the red particle at 1.25 meters, right? So you see these two particles, right, they are 1 meter apart, and that's half a wavelength. Okay, so since they're half a wavelength apart, they are also pi out of phase. Notice their motion are always opposite to each other. Okay, now if you look at the first particle, the blue particle at 0, and then the green particle, that's 1/4 of a wavelength apart. So 1/4 of a wavelength apart, right? Then that will be what we call pi over 2 phase. Alright, so the essential idea here is that in a well, right, so in a progressive wave, the particles, right, always have the same amplitude for all the particles, and within one wavelength, right, they will have different phases. Okay, if I were to use a formula, then I can actually use something similar. So instead of time, it is now the distance along the wave as a fraction of the wavelength times 2 pi. Right, that gives me the phase. Okay, now let's look at the stationary wave. So for stationary wave, as the name suggests, okay, in a stationary wave, right, you can't really tell which direction the wave is traveling. Just now we can see that the wave was traveling to the right, but right now it's just this gigantic oscillation that's taking place. Okay, I've denoted the same four particles, right, that we used just now. So the blue, orange, green, and the red particle. Okay, now look at their displacement time graph. It looks different, right? So let's now identify what are the differences. Okay, so amplitude, right? So the particles have different amplitude. In fact, the one that is at the blue particle, okay, see, this has a perpetual displacement of 0, right? Because there is always no displacement, no displacement, no displacement. If you read it very quickly, right, it sounds like no displacement, So this is the point that we call the nodes, okay? Now the green particle, right, this is at what we call the antinode, so it has the maximum displacement or the maximum amplitude. Phase, okay, so phase is also interesting. See, so if you were to look at the green and the orange particle, right, they have different amplitude, but they're always moving in phase. They always at the same state of vibration: equilibrium, lowest point, equilibrium, highest point. In contrast, if you choose, let's say, the red particle now and the orange particle, right? So the red particle and the orange particle are always undergoing the opposite motion, right? So they're pi out of phase. Okay, so let's summarize. What you will then find, right, it's for a stationary wave, the difference lies mainly in the amplitude as well as the phase difference. So for a stationary wave, the amplitude varies. Right? It goes from minimum at the nodes to maximum at the antinode. Okay, and within one loop, right? Within one loop, all particles are in phase, whereas particles of adjacent loops, they are always pi out of phase. Okay. Now, besides this, there is another difference in terms of energy propagation, but I feel that most students have no problem with this because it's already in the name itself. Right? So, as the name suggests, in a progressive wave, energy must travel. Right? So it travels or gets transferred in the direction of wave propagation, whereas in a stationary wave, okay, the energy is retained within the vibratory motion. It's converted between KE and PE continuously. All right. Okay, so hope that helps.